So here is the situation that we're going to be working through in this video. We need to be able to take the URL of a GIF on the internet or the URL of a YouTube video on the internet, and that's going to be the input. And we want to output something that is a MP4 file that is 3 seconds long and is in black and white and is cropped to the dimensions of an iPhone X, which is the height times 0.462 height. So the height or the width is 0.462 times the height of the video. And this processed media file, which comes from a URL, is going to live in some, let's say, S3 bucket and is going to be used to serve the content for a mobile application. So this is going to be a mobile app. And the processing that is going to be done on these URLs needs to be done in parallel of some sort. So you might have n URLs to process simultaneously, and let's say n is approximately 100. And all of this needs to be done in the context of a web application where a user could take these URLs and put them into some form. You might have 10 people doing it at once, and this processing would just need to happen. So this is a real world scenario that I encountered, but the solution to this is actually quite elegant, and it involves something that you probably have never done before, which is compiling ffmpeg onto AWS Lambda. And I wanted to make a tutorial about this process because it's quite interesting. And there's kind of a lot of surface area that it touches, but this is just a generally interesting thing to know how to do. And the basic practice of being able to compile ffmpeg onto AWS Lambda and use it to parallelize any kind of arbitrary media processing task is just a useful skill in general. So here's a screencast about how to compile ffmpeg onto AWS Lambda and all of my thoughts around it. Now, before I even worry about the Lambda execution environment at all, let's just see how we would get this working locally on our own machine first. So it's the Super Bowl and Tom Brady is playing in it. So we're going to look up GIFs of Tom Brady. And here's a neat little thing that you can do on Google Images is if you go to Tools and Type, you can do Type Animated. And that's essentially going to be a animated GIF search. So we can look at this one. It's like Tom Brady giving like a little fist bump. This seems good enough for the GIFs that we need. So I'm going to I'm going to save the image as actually, and call this tb.gif and save this to my desktop. So if I want to take this GIF and convert it to an MP4, I'm going to use ffmpeg in order to do this. So ffmpeg is a Linux utility for doing video processing, which is incredibly useful, and I use it for a wide range of different tasks. If you want to take a GIF and turn it to MP4, all you have to do is execute the ffmpeg command and pass -i for the input file. So we know that the input file is going to be that tb.gif, and we want to output it as tb.mp4. And this will give us some output about the file. And if we open that tb.mp4, we can see that it's created. It shows up in this VLC player, and this is the GIF. So let's look at how we would add those parameters that we had in the initial spec to this command line arguments. So ffmpeg, you can pass command line flags as parameters into the video processing. So for example, if we wanted to only have the first 3 seconds of the GIF, because one of our things was at 3 seconds, we can call ffmpeg-i tb.gif and then -t for the amount of time that we want in the GIF. So let's say 3 seconds and then tb.mp4 output. And it's going to ask if we want to overwrite it. I'm going to hit Y. But actually a neat little trick you can do with ffmpeg is just pass the -y flag, and then it'll automatically always say yes to whatever prompt it is. So we're going to do that from now on. And now let's open the tb.mp4, and we'll see that this MP4 video is only 3 seconds, which is what we want. Next, let's make it black and white. So we can pass this parameter -vf, which stands for video filters, and then just give it a bunch of kind of key value pairs. So let's say that we want the format of the filter to be gray. And that's how you make something black and white. So let's run this, and then let's open it and see what our output looks like. And this is good. So we have a black and white 3-second clip. And now in order to crop it, this is going to be slightly more difficult because in order to crop a video to the right proportions, you have to kind of do math. on it. So one thing that we can use is a utility called ffmpeg. So ffmpeg is normally installed with ffmpeg. And ffmpeg is a command line utility that just gives you information about a file. So for example, if I did ffmpeg on tb.gif, I would see that it gives us the dimensions of the video. And this is, you could find this in your Finder if you wanted to, but this command line utility is a useful way to do it. And we'll see that it's 500 by 279. And one thing to know about cropping videos with ffmpeg is that it generally likes even numbers. So let's say that we want to make the height of this video 278 and then the width to be 0.462 times that. So I'm just going to open Node real quick and do 0.462 times 278 and I'll get 128.4. So we're going to crop this video to be 278 times 128. That's kind of our goal. Exit out of here and let's run this command again. Only we're going to add one more parameter to the video filter. So in addition to the format equals gray, we're going to say that we want to crop the video, and we're going to say the width is equal to 128 and the height is going to be equal to 278. And this is the format that it expects for that. And let's hit enter. And finally, let's open up that tb.mp4. And we're going to see that we have that cropped video in exactly the format we want. So it's black and white, it's scaled to the correct dimensions, and it's exactly 3 seconds long. And all that we needed to do that was to run this exact command with ffmpeg. So this is locally on our machine. And the question is now how we can run this in the context of a web application in a way that's parallelizable. And that's where this adventure is going to get kind of interesting. So my idea now is that I want to kind of extract out all of the local state associated with my own computer. Why am I able to run that ffmpeg command? Well, it's because I have ffmpeg installed on my Mac. But ffmpeg is this, kind of heavy library that has a lot of dependencies associated with it. So my first question would be, I wonder if there's a static binary for ffmpeg. Now, static binaries are really cool because the basic idea is that you take the executable, that ffmpeg executable, and you package it in a folder where all of its dependencies are just encapsulated in that binary as relative paths to ffmpeg. So you just have a folder that has all the dependencies with it, and you kind of extract out any local machine state that you have. So let's take a look if there's an ffmpeg static binary. And it turns out that there is these ffmpeg static builds hosted by this guy named John Van Sickle. And there's a lot of them, and all of these are meant to run on Linux, which we will get to in a second. But let's go ahead and download one of these static binaries just to take a look at it. So I am just going to copy this link right here, and I'm just going to run wget. Now, you probably don't have wget on your Mac because it's normally a Linux thing, but you can just brew install wget. I always install this locally on my Mac because I kind of think that it's useful. And then we're going to have that ffmpeg git amd tar.exe. In order to extract that, you can just run tar-xf on that crazy ffmpeg thing, and this will extract it into a folder. So now we have this thing called ffmpeg git static or whatever, and if we go into it, we'll see that we actually have that executable binary for ffmpeg and ffprb, only when we call this, all of its dependencies are packaged relatively to it, and it doesn't rely on any outside computer state. So let's real quick just rename this. So mv ffmpeg git whatever this thing is to ffmpeg static, let's call it. And let's just try to run this. So let's do ffmpeg static and then call ffprb on, let's say, that tb.gif file and see what happens. And we're going to get this exec format error. And like I said, it's because this ffmpeg static binary is meant to be run on Linux, which is good because we're going to be running this on Linux in production, but we can't run it locally. So the thing we have to do now is figure out kind of like a local workflow to be able to prototype doing this on Linux. Now remember, the overarching idea here is that we want to compile ffmpeg onto an AWS Lambda function. So it would be good if we had something locally that resembled the execution environment of AWS Lambda. And a good way to do that is by using Docker. So Docker is a way to create really lightweight, bare bones Linux containers, but that's essentially the environment that you're going to have running on Lambda. So I'm going to make a new directory called VM, and I'm going to cd into it. And I'm going to move that ffmpeg folder that had all the static binary into this thing here. And then I'm going to create a Docker file. So let's touch a Docker file. And then let's open this entire folder with Atom. Okay, so we're here and we have a Docker file. I'm gonna make this text a little bit bigger. And I'm gonna do from. Now, every Docker file starts with a from command and you say the Docker container that you wanna pull from. I'm gonna pull from node 810. And the reason I'm doing that, if we open up our console, when we're going to create our Lambda function, we're going to, let's say like we go to create a new one, it's gonna have a bunch of language execution environments that you can choose from. Node.js 810 is what we're gonna actually write the code for. So that's why I'm writing a Docker file that's gonna have the Node.js installed. And all I wanna do is make a directory that is called -lambda function /source and points, if you remember the -p in your make dir commands, which will tell it to make intermediary folders. And then we're going to copy that ffmpeg static build into the lambda function /ffmpeg static. And then I'm going to copy that Tom Brady GIF also. I want to copy that Tom Brady GIF to the Docker folder also. So let me actually move it from here. Yeah, and then I want to copy tombrady.gif into my Lambda function folder. So yeah, that's all we need to create a simple Docker container. So let's docker build -t, and we'll call this just node 810. And we need to give it the path, which will be this folder right here. And again, this isn't really a tutorial on Docker, but it's just kind of useful to watch this stuff. So anyway, now that we have this built, we can docker run -it, and we can give it the name that we tagged this with of node 810. And let's give it the /bin/bash so that we have a terminal prompt. And we can see that we're now in this Docker container, which is going to be kind of similar to the execution environment on Lambda. We wrote this folder for Lambda function, and we'll see that we have that ffmpeg static folder, and we have that tb.gif. So we're going to try this. Let's do /ffmpeg static /ffprobe, and then give it the tb.gif as the input -i tb.gif. And we'll see that it actually runs. So again, this is kind of cool, right? Because we never had to install all these dependencies. We're just running the ffprobe binary out of the static binary file on that GIF, and we'll see that it works. And we can actually run ffmpeg also. So instead of ffprobe, let's run ffmpeg, and let's make it into a tb.mp4 as the output. So it looks like it worked. And now if we wanted to pull that down locally, we could run docker cp. Actually, I need the ID of this thing that's running. So it's A44 is the container ID. So if I did docker cp A44, and then it's like .lambda function /tb.mp4, and we just copied it to our desktop, and then we open tb.mp4. Yeah, we'll see that. So we pulled that out of the Docker container, and you can see that it is actually running ffmpeg. So now we have a really simple execution environment that we can use to run ffmpeg. Now that's really cool. And we're going to be able to compile this and run it on AWS Lambda. But the question now is how we can actually write code that can do this. So how do we actually write the code to run as a Lambda function that can call out to the ffmpeg that's going to be packaged locally? So now I want to write code locally that I can execute on my Docker machine. So a good way to do this is to do a slight refactoring and make a Docker compose file. So I'm going to exit out of this Docker instance, and I'm going to get rid of this line right here. And instead, what I'm going to do is create a Docker compose file here. So docker compose.yml. And in this, I'm going to do version 2, services, and node.js. And I'll say the build directory is right here because that's where the Docker file is. And then volumes, I want to mount the local ./src folder, which does not exist. So I'm going to create that here, src. And I want to mount this to Lambda function /src. So basically, I'm going to say whatever is in my local src, just sync that to what's in this Docker file src here. And then I'm just going to take the ffmpeg static build and put it there. So if I do this little refactoring here, and then I just run docker compose up, well, you'll notice that it's going to start up, but then it would just immediately stop because I have to add this TTY in here. So if you add TTY true, then the Docker Compose will just hang and it'll stay open so that you can SSH into it. So let's run Docker Compose up. It's going to attach that VM and it's going to continue running, and we do Docker PS and we'll see that we have a running container 089. So we could SSH into it by doing docker exec -it 089/bin/bash, and now we SSH in. And we'll see that we have that Lambda function directory. So if I cd into it, we'll see that we have that src. And I guess that ffmpeg static exists at the higher level also because I forgot to rebuild the container, but whatever, let's just ignore that. So now this will just synchronize to whatever I have locally in my src folder here. So if I make an index.js and I just say console.log hello from a JavaScript file, now I could see this. Here I have that index.js, and if I just ran node index.js, we'll get hello from JavaScript file. So we have this environment now where I can write some code locally and have it execute on the Docker container. So now the question is, how are we going to actually call that ffmpeg binary from JavaScript? And we're going to use a library called child process, which is just a default library on Node.js. So we can require it by doing const child process equals require child process. And I'm also going to require the default library path. And I should note that these are just default Node.js libraries. And let's require ffprobe path, because ffprobe simpler than ffmpeg for right now. And we'll say this is equal to path.resolve _ dir name, which is JavaScript shortcut for the directory that this file is being called from. And then let's say ffmpeg static. And then let's add ffprobe. And likewise, we could say that the path of the ffmpeg executable is the same thing, but just with ffmpeg as the actual command. And now in order to execute this actual binary, we can use, like I said, that child process library. And we can say var proc is equal to child process.spawn sync. And spawn sync will just actually execute synchronously against the shell environment, and it will store the variable of what is returned. So we can say, let's execute that ffprobe path with some arguments. And I guess we should make a ffprobe args, and we can just pass, an array of the parameters that we pass in. So it was -i, and then let's say tb.gif, because there's a tb.gif at the root of this directory. And then we'll give it the ffprobe args. And then we can console.log proc.standard_error. And this is standard error is where the output from ffprobe is going to get logged to. Don't ask me why it stores it on standard error and not standard out. I'm not exactly sure, but this is just what you have to do. And then toString, because it is default as binary data. So let's just run this and see if it works. So we saved it here. And then we should be able to run just node index.js. Yeah, and we'll see that what we get is the actual output of ffprobe, and it's failing because it doesn't know where there's a tb.gif. And I guess that's because we need to copy it from the root directory. So that's my bad. And then let's copy it here. And now let's run that same command again and just see what happens. And yeah, we get the output of ffprobe. Now, what's interesting here is that this output is not from the command line invocation. This is actually coming from running this JavaScript file. And the JavaScript file, again, is shelling out to the child process here on the command line. So just to take a step back for a second and look at the kind of high-level idea about where we're going, is that we are going to have this .js file that's going to be deployed on AWS Lambda as a Lambda function. And this is going to be able to shell out to that ffmpeg static binary that's going to be compiled with it and deployed on AWS Lambda. Now, we are going to call this Lambda function from the context of a web app, and we're going to call it with a URL. So that will be one of the arguments passed into the invocation of the Lambda function. And then we're going to need to download the data from the URL. So we're going to take the data of the URL, we're going to download it into a temp file, then we're going to pass that temp file into ffmpeg to process the video, and then we're going to write the output, the new process video, to another temp file. And now we have that second temp file, and we want to upload that temp file to S3. So that's a way that we can take URLs and upload them to S3 processed in a parallelizable way, because this entire thing here is going to be deployed on AWS Lambda.